Math 1332, Chapter 10, Probability and Counting Techniques. Section 4, Tree Diagrams, Tables, and Sample Spaces. Video 1, Calculating Probabilities Using Tree Diagrams. And yes, that background is the Death Star. Suppose you're at a restaurant and their menu is very simple. You can choose one of two appetizers, soup or salad. You can choose one of three entrees, steak, chicken, or fish. You can choose one of two desserts, pie or cake. Now, this may sound like a very familiar problem because we've seen something like this when we were first learning about the fundamental counting principle. In fact, from the fundamental counting principle, we know that there are 2 times 3 times 2 equals 12 possible meals. Remember how the fundamental counting principle works. If we are making a sequence of decisions and each decision has a certain number of choices, then the total number of ways we can make all the decisions is multiplying all the numbers of choices. For example, we're choosing one of 2 appetizers, one of 3 entrees, and one of 2 desserts. And so 2 times 3 times 2 is 12. Let's say you choose one meal at random. What is the probability you have steak but not cake? Well, we haven't seen probability in a few videos, so let's kind of remind ourselves how to approach this from a theoretical perspective. Using theoretical probability and assuming equally likely outcomes, we could easily calculate this if we knew 2 values, the number of ways to pick a meal with steak but not cake, and the total number of meals possible. We already know the second value, 12, but what about the first? When an experiment consists of making multiple decisions in a row, we can use an illustration called a tree diagram to not only visualize the sample space, but locate outcomes in a desired event, such as having steak but not cake. And once we know the number of outcomes in that event and the total number of outcomes, the ratio forms the probability of that event happening. So here's how to construct a tree diagram. A digogram. I'm not even going to pause the video to correct that. And I even looked this over to make sure that I did not make any typos. It's been a long day. Here's how to construct a tree diagram. All right, I'm going to be going back and forth between this page and this page as a reminder of our choices that we have to make. Appetizer, soup or salad, entree, steak, chicken or fish, dessert, pie or cake. The way you make a tree diagram, there's actually 2 ways to do a tree diagram. Vertically going down or horizontally going left to right. Not sure which direction that's moving for you, but horizontally going left to right. Sorry, my ear itches. I choose to do tree diagrams vertically because as you draw a tree diagram, it gets larger in the other direction. So like if I'm drawing a vertical tree diagram, it's going to spread out horizontally. So I want more room to go horizontally. If I do a horizontal tree diagram, it will spread out more vertically as we go. And because the screen is landscape and not portrait, I have more room to go sideways than down. So my tree diagrams will always go top to bottom so they have plenty of room to spread out. But here's how you construct a tree diagram. The first thing you do is start with what's called a root, which is a single point. If I can get this to draw. So you start with a root. Then you're going to branch out from that root based on how many choices you have to make for your first decision. Our first decision is appetizer, so I'm just going to write appetizer over here. And then you set out 1 branch for each choice and make them spread out wide. You'll see why in a moment. The first branch could represent our first choice, which is soup. And the second branch could represent our second choice, which is salad. That takes you to another layer of branches. From the branches that you already have, you're going to branch out again for using the choices for your second decision. Now, our second decision is entree. And remember that for the entree, we have 3 choices, steak, chicken, or fish. So from each of the appetizer branches, we're going to branch out once per entree. 1, 2, 3. 1, 2, 3. And our entrees were steak, chicken, and fish. Normally I would write the words on the lines, but it's a little tricky with the, well, maybe I can do it. Steak, chicken, picked up my laptop, and fish. So now we have 2 layers of branches. And although this isn't part of the tree diagram, it sometimes helps to see a line going across that separates each decision's choices. So above that blue line is my appetizer choices. Below it is my entree choices branching out from each of the previous appetizer choices. Then we do it again for the next decision. Our next decision is dessert. Oops, excuse me, that's still drawing a line. I wanted to draw whatever I write. Our next decision is dessert. And you can tell I'm already running out of room. And I keep hitting the edge of my screen and my computer does weird things. So for dessert, we have 2 choices, which means from each of the previous branches, we're going to branch out twice, once for each dessert choice. Our dessert, where am I from? Our dessert choices were pie or cake. And for simplicity, I'm just going to put P for pie and C for cake. But we have to do that from each of the previous layer of branches. Pie and cake. 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 Once you've represented the last layer of branches for the last decision you have to make, the ends of all the branches each represent a possible outcome in the sample space. For example, let's take this branch. Do you know what meal that represents? To know what choices a branch at the end of the tree represents, go back to the root and trace it from the root to the end of that branch. Soup, chicken, pie. So that third branch at the bottom represents choosing soup and then chicken and then pie. What does this branch represent? Start at the root, trace it out. Salad, steak, cake. And if you'll notice, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 branches at the end, which is in agreement with the fundamental counting principle that said there were going to be 12 possible ways to choose meals. Each branch is a unique meal. And now that we have that, we can answer the probability question. Remember, we're looking for the probability of randomly selecting a meal that has steak but not cake. From what we know about theoretical probability, we know the denominator is going to be the size of the sample space, but we already have 2 pieces of evidence to say that that's 12. We have the fundamental counting principle, which we did here, and we also have this tree diagram with the 12 branches at the bottom. But the numerator has to be the number of events that belong to this, the number of outcomes that belong to this event, the event that you have steak but not cake. So one at a time, we have to figure out which branches we want. And we can kind of do this by process of elimination. If we have steak, then we don't want the chicken branch or the fish branch on either of these. And of the ones that are remaining, we don't want cake. So let's get rid of the ones that have cake. How many branches are left? This one and this one. The first one represents soup, steak, and pie. The second one represents salad, steak, and pie. 2 of the branches represent having steak but not cake out of 12 branches, so the probability is 2 over 12, or 1/6. Now, is there another way to get 2 out of 12 besides this picture? Of course there is. We really didn't have a choice on the entree. It was steak. And we really didn't have a choice on the dessert. It had to be pie. So the only choice we really had to make was the appetizer, and there were 2 choices. But using a tree diagram can really help organize your thoughts because it gives you a visual for all of the possible outcomes in a sample space when you have to make a sequence of decisions. The disadvantage to a tree diagram is it can get out of control really fast. For example, let's say instead of having 2 appetizers, 3 entrees, and 2 desserts back here, let's pretend for a second that we had 4 appetizers, 4 entrees, and 3 desserts. That's not that many more choices, but if we multiplied 4 times 4 times 3, that would be 48, which means our tree diagram at the end would have 48 branches going across. You can imagine how congested that would get. So in theory, tree diagrams are good, but in practicality, only when you don't have a lot of decisions to make and each decision has a very small number of choices to make. We'll do a couple more examples of tree diagrams because they really can help organize your thoughts.